This one is also a little tricky. And again, remember that you're not expected to just look at these and be able to automatically do them just right off the top of your head. You have to sit there and think about these to figure out what's going on. We're looking for the mass. So the only equation that we know of right now that has mass in it is our density equation. That kind of gives us a big heads up that, hey, we're using density equation. And they tell us what the substance is. So that means we can look up the density and we could use that to figure out what it is. Now they give us the diameter and they give us how long this wire is. So we have to stop and think, what geometric shape is a wire? It's not a rectangular prism. It's not a sphere. It's a cylinder, right? So we have to use our cylinder equation for volume, which is pi r squared times h. So we're looking for the mass eventually. They don't give us the volume, but they give us a way to calculate the volume. They give us the diameter, so we don't use diameter in our volume equation. We use radius, so that means we have to take that diameter divided by 2. They give us the length, which essentially is the height of our cylinder. And our density, we look up on the density data table and we find that the density of copper is 8.92 grams per centimeters cubed. Since we're looking for the mass, we got to figure out what our mass equation is. Rearranging our density formula, we get mass is equal to density times volume. However, they don't give us volume, we have to calculate it. We know the volume of a cylinder is calculated by the formula pi r squared times h, or times the height. We're going to substitute that in for the volume in our density formula. We end up with an equation where mass is equal to the density times pi times r squared times the height. So we're going to start plugging in our numbers. So remember, this d is density. We have to remember that it's not diameter. So that's why I wrote diameter as dia. So 8.92. Again, grams goes with the number. The centimeters cubed is going to go on the opposite side of our line. And again, you can put the 1 with it or you can leave it off. It doesn't matter. Just make sure you split them up. If you put, g/cm cubed on the top, then you have a complex fraction. And unless you're good at manipulating units that are in fractional form, it becomes very difficult to solve. So we're going to multiply by pi. Now we're not going to write down 3.14. We're actually going to use the pi key on our calculator. That's going to give us a lot more significant figures. So we want to use as many as we can. Our radius is squared, so we're going to take our diameter and divide it by 2. And we have to do that twice because it's radius squared. It's radius times radius. So we have to take our diameter and divide it by 2 again. Now we could have avoided that by over off this side calculating our radius and showing that work. We have to show that work. You can't just do it. Then we're going to multiply it by the height. So that's our length. So that's 100.12 meters. Now you'll notice that I got millimeters times millimeters times meters. So those can't combine. They have to be the same unit in order to increase the exponent. So that means we're going to have to add in some conversion factors. So I want all my length units, my distance units, to be in terms of centimeters so that they'll cancel these centimeters out. So I got centimeters cubed on the bottom, which remember is centimeters times centimeters times centimeters. If I look on my conversion factor data sheet, and specifically the metric side, I find that 1 meter is equal to 100 centimeters. Since I want meters to cancel, I put my 1 meter on the bottom and my 100 centimeters on top. So that's going to cancel out the meter, and then that centimeter will cancel out the cube and change it to centimeters squared on the bottom. So I'm running out of room, so I'm going to extend this line down underneath. I want millimeters to cancel and I want centimeters to cancel. So I got to somehow either use both of these conversion factors to do that. Okay, so to do that I would have to put 100 centimeters on the top, 1 meter on the bottom, then I put the 1 meter on top and 1,000 millimeters on the bottom. But since they're both equal to 1 meter, I can combine this together into a conversion factor that says that 1,000 millimeters is equal to 100 centimeters. And if I divide both sides by 100, that changes this side to 10, and it changes the other side to 1. So 1 centimeter is equal to 10 millimeters. If you're not sure how I got that, you can just use that top one and you'll still get the right answer. So I'm going to put my, since I want millimeters to go away, I'm going to put my 10 millimeters on the bottom and my 1 centimeter on top. So since the millimeters on the bottom, that's going to cancel out one of the millimeters on the top that's over here. And then since I have a centimeters on top, that's going to cancel out with the centimeter on the bottom. Since I have centimeters squared, which remember is centimeters times centimeters, that cancels the square and turns this into just centimeters. So that means I got to do that step one more time. Since I want millimeters to cancel, I take the 10 millimeters, put it on the bottom, the 1 centimeter, put it on top. The millimeters on the bottom cancels with the millimeters on the top. The centimeter on the top cancels with the centimeters on the bottom. So now I'm left with units of grams, and all I have to do is calculate it. So everything on the top we're going to multiply together, and anything that's on the bottom we're going to divide by that. And we end up with 7,871.64. If I would have noticed this a while ago, you'll notice that we have 10 times 10 on the bottom, which if you remember is 100. So if you notice that, then you can go ahead and cancel that out. That 100 on the top will cancel out the two 10s on the bottom and make your problem a little bit simpler. So the last step is to figure out the number of sig figs. So we're multiplying and dividing, so we go with the least number of sig figs. Remember, conversion factors have an infinite number of sig figs. This 2 that's true by definition. The radius is 1/2 the diameter. That is by definition. So that 2 is an exact number. It has an infinite number of sig figs. The 3.35, however, only has 3 sig figs. 8.92 has 3. The 100.12 has 5. Pi is going to have a bunch because we're using the pi key. If we use 3.14, then we'd have 3 sig figs. So our answer is going to be good to 3 sig figs. So we start from the left, 1, 2, 3. We mark it, then we look to the next number, which is a 1. 1 is less than 5, so that tells us that the last sig fig, that 7, is going to round down, which means we just chop it off. So 7,871.64 rounds to 7,870 grams without a decimal point. If I put a decimal point there, then it has 4 sig figs. I want it to have 3. So no decimal point. And that's our last example. Hope you learned something.